Okay, students, sorry I'm not here today, but I'm going to walk you through the warm-up that you just did. And what we have here is a motion graph. And what has happened is we have an object in motion that is going from the negative quadrant to the positive quadrant, has a couple times where it's at rest, a couple times where it's moving with positive velocity, and at least one time where it's moving with a negative velocity. The first question, it says, what is the initial position of the object? Well, the initial position is where the line crosses the vertical axis. So in this case, we can draw a line, put a dot right there, and recognize that where the line crosses the vertical axis is at -4. So x equals -4. Biggest deal there is knowing what that is the initial position of the object. That is where the object originally started on our number line. The next question, it says all of the times when the object is at rest. Well, that is when the object, or where the line is flat. So anytime the line is flat is where our object is at rest, because it's staying at the same position as time continues to tick on. We can't go back in time, we can only go forward in time. So if I stand still as time continues to go, the time moves, but I stand still, so the line appears to be flat. And there are two moments where that happens, and time equals 2 seconds to 4 seconds, and where time equals 6 seconds to 7 seconds. Those are the two moments where I am standing still with initial position, or with the same position that I started 2 seconds later. So I started at -4, I walked forward and stopped at 6 meters away from the motion sensor and stood still for 2 seconds. So it took me 2 seconds to get to 6 meters, and then I stood still from 2 seconds to 4 seconds, then I moved again and then stood still from 6 to 7 seconds. The next point of this is we need to find the velocity of the object at time equals 1 second. And we know this also known as instantaneous velocity. Now, instantaneous velocity is the velocity of an object whenever it at a certain instant. It's the velocity of an object at a certain instant, or at any given time. So we've given you the time as 1 second. Okay? So we have the velocity of an object at a precise instant in time, and it's also the slope of the line segment. Okay? So we have our instantaneous velocity at time equals 1 second, and what we end up having to do is find the slope of the line at that particular point. So we go up from -4 up and over, and draw a little triangle there, and when we go up, the length of that side of the triangle is +5. So -4 to 1 there is +5, and then going over is going to be +1. And so the slope of that line, rise over run, the velocity at that instant, at that 1 second, is the slope of that entire line segment, and it's 5 meters per second. Okay, so let's try that again. We need to find the velocity of the object at time equals 5 seconds, and it's going to end up being -2 meters per second. And how we found that was we found the velocity of, or the slope of that line. We went down 2 over 1. Some people went down 4 over 2. It doesn't matter as long as you find the slope of that line, and I got it to be -2 meters per second. And since it's velocity, the negative means it's like south direction or left. It's negative is a direction. So that's how we notice that. The next thing is finding the average velocity. And average velocity is using the equation where velocity equals the change in x over the change in time. And that is basically the same idea as saying that average velocity is total displacement over total time. So total displacement over total time. Okay, and we also can find average speed, and average speed is the same idea. It's just total distance over total time. Total distance over total time. So what we have to find the final position of our object. So we place a dot there, and that dot happens to be at 5 meters. As far as the vertical axis is concerned, its position is 5 meters, and its initial position, our original position at the very beginning of the graph that we found in part A, is -4. So 5 minus -4 turns into +9. And the entire time of this graph, for me moving up or moving in a positive direction, staying still, moving in a negative direction, staying still, and then moving in a positive direction again, the entire time it takes me to do that is 10 seconds. And that 10 seconds goes on the bottom, so it's the total time. And I moved 9 meters in 10 seconds. And you could also draw a vector, a resultant vector, which you see me draw here, and you can find the slope of that line as well. So it's also the slope of the resultant vector. Now, finding average speed's a little bit different. You have to find how far the person walked on each line. So line 1, I went from -4 to 6, and that total distance is 10 meters. Line 2, the line segment number 2, I didn't move, so I didn't move any meters at all, so 0 meters. Line 3, I moved from +6 to +2, so I'm going to remove my little vector there, and I moved from +6 to +6 to +2, which is technically -4, but we're only going to write it down as +4, even though it's negative. The negative doesn't matter. When we're looking for distance, it's always positive. That's why it's a scalar quantity. We just want the magnitude only, no direction, and a negative is considered to be a direction. Now line 4, again, I stay still. So it's again 0 meters, just like line 2. And then line segment number 5, we move in a positive direction of 3 meters. So our total distance is 10 plus 0 plus 4 plus 0 plus 3, and that is 17 meters, and the total time it took us to do that was 10 seconds. So we end up with 17 meters in 10 seconds. So that is our speed, our average speed. If I wanted to find instantaneous speed, I would do it the exact same way as instantaneous velocity. I would just take off the negative, because the negative is a direction. Okay, now, next page. See if I can't get to the next page. There we go. There's the next page. So what we have here, oh, I'm messing this up. There we go. That's what we want. We want that. That works. On this next page, we have your assignment for today. It's graphing story problems. And so what I have is that Bennifer and Brangelina are leaving school at the same time and walk home together. Bennifer is 500 meters from school, and Brangelina's house is 200 meters further in the same direction. After leaving from school, it takes them 10 minutes to reach Bennifer's house. At this point, they stand outside and talk to each other for 2 minutes, and then Brangelina runs home in just 1 more minute, and we're supposed to put this on the graph. So I need to find the values for my line, and since I have a total of 700 meters that I have to travel for position, and I have a total of 14 lines, 700 meters divided by 14 lines is considered to be 50 meters. So each line needs to be a value of 50 meters. So what I've done is I've marked all those points and labeled them to be 100, because each mark is 2 lines, so 50, 100, 150, 200, and so on and so forth. And I go all the way up to 700 at the top. I'm not going to write it because I don't have room. And that's based on the idea of my max value being 700. I also have 14 lines for time, and the total time it takes is 13 minutes. So 14 lines, 13 minutes, 13 divided by 14 is just below 1, so we'll round that up to 1. So every line has a value of 1, and I'm skipping and putting 2, 4, 6, 8, 10, 12, 14, even though the value of every line is 1. So max value on the position axis is 700 meters, and max value on the time axis is 13 minutes, and we end up having 14. We have 1 extra line, but we use the entire graph. So at this point, what I have to do is draw what happened. And so what happened is that they walked 500 meters in 10 minutes. So I place a dot, and I have 3 black dots here. I place a dot at 500 meters and 10 minutes, and I go ahead and draw a line there. We're not doing a best fit line now, we're actually graphing motion, so I draw a line there. And then the next one, they stood still for 2 minutes. So that means I'm flat. Position didn't change. We were at rest. So 2 minutes later, put another dot, stay at 500, and connect the dots. And the last one, I went from 12 minutes to 13 minutes, and I traveled 200 meters. So it's a very steep positive line. And so I connect those two dots and put my new dot there. And so now I've connected all those lines. And this is the how you graph motion. I give you a graphing story problem. You graph what happened. Now, what I would like in the extra space, I would like you to write an explanation. So, that first line is a positive slope, so it means I was moving with a positive velocity. The second line, I was at rest. And the last line, I was moving at a positive slope, but it was greater than the first one. So I would like you in the margins of your graph, out in this space here, and here, or here, you don't have to write that max value stuff like I did, but out in that space, I would like you to describe line 1, 2, and 3 on your graphing story problems. And then on number 2, which is now labeled number 3 for some reason, I guess I misnumbered, where Zender and Zach, everything's in miles there, so you can change the change the vertical axis to miles and do the same thing. I need you to write in the margins what happened for each line. And move on. And there's also one on the back. So I've done one example for you. Finish this in class, and hopefully everything is easy peasy lemon squeezy.